All right, guys, so let's go ahead and take a look at recursion and linear functions today. All right, so this question. Cohen decides to take a job with a company that sells magazine subscriptions. He is paid $20 to start selling them and earns $1.50 for each subscription he sells. Fill in the following table showing the amount of money M Cohen earns for selling N subscriptions. Use the process column to note what is happening in each line. Okay, so this is saying right here, so N represents the number of subscriptions. So let me make that here, number of subscriptions. Okay, we've got that. And this M sub N right there, that's going to be our amount of money. In this scenario, when Cohen has sold 0 subscriptions, how much money does he have? Well, it tells us right here in the very beginning here that he is paid, here, he is paid $20 to start selling, then earns $1.50 for each subscription that he sells. Okay, so that's some useful information right there. So if we've sold no subscriptions, we've at least got that $20. So that's what we're going to put here. We got $20 right here. Okay, so if we've sold one subscription. Well, if we've sold one subscription, we have that $20 that we originally had, and then we're going to add $1.50 because we get the $1.50 for every subscriptions that's sold. So that means if we've sold one, we've made $21.50. So likewise, if we've sold 2 subscriptions, um, there's a couple ways you could do this. You could do 20 plus $1.50 plus $1.50, but that's not what we're really wanting you to do right here. While it's not wrong, that's not talking about necessarily kind of looking at what we're wanting to do here. What you want to consider is we're just going to use what we had previously. Because if I asked you 17 subscriptions, are you going to want to go $1.50 plus $1.50 plus $1.50 plus $1.50 and do that 17 times? No, you're not. It's a lot easier to just use that previous one that we just had. So in this case, that would be that 21.50, and we would just add $1.50 to that. Okay, so we just take the last one and then we add the $1.50 again, and that's where we have our next one, which would be $23. Then we could go ahead, figure out, okay, if we sold 3 subscriptions. So again, I'm not going to go 20 plus $1.50 plus $1.50 plus $1.50. I'm just going to take this 23 and add $1.50 to it. And that's going to get me $24.50. Okay, and so then the last one, if we've sold 4 subscriptions, that's going to be that $24.50. Taking that last one that we just had, adding $1.50 to it, and that's going to get us $26. Okay, so with this process right here, what we're looking at here is just kind of a constant repetitive process, which is what we have here for recursion. Um, So we're going to kind of be talking about that really for this entire unit, to be honest. There's a lot about recursion. Write a recursive rule for the amount of money Cohen can earn selling magazine subscriptions. So in this particular case, let's consider something that you've already done in the past. You've done something in the past where you have something like, for example, 5, 10, 15, 20, 25. So you see, like this right here is just a sequence of numbers, and you and I could tell, you could all just sit here and tell me exactly what the next number is going to be. We should all look at this and know the next number would be 30. We can see the pattern is that it's increasing by 5 every single time. So I just take the previous one and I add 5 to it. And that's exactly what I have here. And so if I was to take this information and write some sort of recursive rule about that, then that's a bit more straightforward because I'm just looking at numbers that I can see and I'm just like, oh, okay, I'm just going to add 5 each time. That's really easy to see. If I was given a list of numbers that weren't necessarily clear, then it might be a little bit more challenging. But here's what we've got for this one. So instead, a recursive rule Basically what that's going to be doing is that's going to be taking a list of numbers that you have, and you're going to be applying some sort of rule to a set value and constantly repeating it over and over. So in this particular case, what we're going to go ahead and do is we're going to take what we have here. We're going to say, okay, so our money earned for some n value, we want to know what is the next number. And so the next number, you're going to take this m sub n right here, and you would add $1.50. And we're adding the $1.50 because it's $1.50 for every magazine subscription. So in this particular case, M sub n is going to be representing our amount of money that we've got, right? And so if we've sold 0 subscriptions, so the n right here, so if I consider n is the number of subscriptions, okay, so I've got that. And M sub n is the money that we have based off of those subscriptions plus that base amount of that $20. That's what we have here. So if I'm considering right here in this initial one here, this M sub n, if I consider that as my initial term when n is 0, when I've sold 0 subscriptions, right? Then when I've sold 0 subscriptions, I've made $20. Now, obviously, if I've sold 0 subscriptions, I don't have $20 plus $1.50, right? But that's why over here, this M sub n plus 1 is saying this is where I've had 0 subscriptions plus 1. So I've sold 1 subscription, okay? Because if this is 0, this is also 0 right here, because they're both M sub n, but this one has that plus 1. This n is still going to be the same number. So if I've sold 0 subscriptions, I still have that $20. And then, but if I want to figure out what I have from selling 1 subscription, then I take, well, let's take 0 subscriptions and add $1.50. Likewise, if I wanted to find selling 3 subscriptions, for example. So if I wanted this one to be 3 over here, that means that I need to know how much did I have when I sold 2 subscriptions. And then I would just add $1.50 to it. So that's what we have for this one. Now, when writing this recursive rule, we can't just leave it as just this as it's written here. We would need to go a little bit further, and we would need to say where n is equal to 0, 1, 2, 3, and so on and so forth. Or you could also just say n is greater than or equal to 0. Now, I'm saying it here like this because when n is 0, that is my initial amount. That works. Is it always going to be that way? Not necessarily. I'm sure there's going to be some time where it's not, but general rule of thumb is that it's going to follow this pattern. And then what I also need to state is, and m sub 0 is equal to 20. So this is that initial amount. So I'm stating how much money we would have when we sell 0 subscriptions. And I'm stating how those n values are going to be changing. And they're going to be increasing by 1s and starting at 0 and it goes on. That's what this is. It starts at 0 and then goes 1, 2, 3, and then this dot, 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 the ellipses here is continuing it on forever and ever. It doesn't give me an ending to my, limitations here. There's no limitations on Cohen's magazine subscription selling, I guess. But what if do you notice here how it cannot be a negative n value? He can't sell negative magazine subscriptions. So that's why this n value here is starting at 0 and then it's increasing from there. Okay, so then next. The rule in question 2 defines a term m sub n plus 1 with respect to the term that precedes it, m sub n. Write a rule that defines a term m sub n with respect to the term that precedes it, m sub n minus 1. So basically all this is saying, if you consider here, so the question that we just did right here, that's saying it's taking a term m sub n plus 1, this term right here, and it's saying it's defining that by taking the previous term and adding something to it. It wants me to write a rule that defines term m sub n, so this m sub n term, with respect to the term that precedes it. So that would be m sub n minus 1, right? Because if this is what I have right here and I want to know the term before that, well, that would be n minus 1, right? Because that would get me the one before it. Okay, so let's consider what that's going to look like right here. So I have m sub n, and then what I'm going to do there, that's going to be m sub n minus 1, right? Because that's the term before it. So this is the term, and this is the term before it. And then I'm adding $1.50. And then here, what I would go ahead and say here is where n is equal to, and let's consider what we have right here, okay? If I put 0, okay, if I put where n is equal to 0, 1, 2, 3, like I had right here, well, what would be 0 minus 1? That would be negative 1. I can't have a negative 1 here because I don't know what I'd have if I have negative 1 subscriptions sold, right? So I do just kind of have to consider that right there. So instead, I'm going to make it be what would make this part right here, what would make this be 0, because that's what it needs to start at. And that would be when n is equal to 1, 2, 3, so on and so forth. Okay. And then we would also state when n equals 0, m sub 0 is equal to 20. Okay, so they're very, very similar to each other if you notice that, okay? Basically, what you're looking at here is you're looking at the exact same rule where this one right here is taking the term before it and adding $1.50. Well, this right here is taking the term before it and adding $1.50. So really, you can see these recursive rules however you want to see them. You've seen them multiple times in multiple math classes. You've probably even seen them if you've taken physics, and maybe even some other science classes would have had them as well. But you've seen them, so depending upon how it's been presented to you, they're all kind of the same. But it's just kind of thinking about how to look at it and where to consider it from. Okay. Now, write an explicit function rule with the nth term in the sequence describing the amount of money Cohen can earn. Describe any domain restrictions on your rule, and how is this rule related to the rules that you wrote in question 2? So if I go ahead and look at that, what I'm going to go ahead and do, let's make sure that I'm clear here. Explicit function rule. So an explicit function rule is all I'm doing is I'm just writing an equation similar to what you're used to seeing. For this right here, you're used to seeing things like a linear equation, an exponential function, quadratic, things like that. That would be an explicit function rule, okay? We could have other different situations where we would not be using it as an explicit function rule, and that's our recursive function. And the recursive function is what's kind of new to you guys, and that's, well, I shouldn't say new, but it's where you're going to be writing something based off of the previous term. So explicit function rule, when you see that kind of phrasing, that's referring to stuff that you're used to. So that's where you have an input-output relationship. So you input a number and get an output back. And so for this one right here, an explicit function rule would be where I have the nth subscription. So however many subscriptions we've sold is where I take that initial $20 that we have, and we're going to take $1.50 and we would multiply that by however many subscriptions we've sold. This is kind of what you guys are used to seeing, and I bet every single one of you would be able to come up with this on your own if I asked you to go ahead and create an equation for this. You might not necessarily write it as m sub n, but you guys would recognize that you started at $20 and you're going to add $1.50 for every single subscription after that. And I would say overwhelmingly you guys would be able to come up with that. And that's the basic part of the explicit function rule. You just have to define it a little bit further and say where n is equal to 0, 1, 2, 3. And that's that describe any domain restrictions in your rule right there. That's that domain restriction is discussing that right here. Because again, we can't have a negative subscription, but we can have 0 subscriptions sold, and that would get us $20, right? Because 20 plus $1.50 times 0, that $1.50 times 0 would still be 0 right here. And so it would be 20 at the end. So that's exactly what you have here. Now, if you compare this equation right here to our equation that we wrote over here in 2, if you notice, this says m sub n plus 150. So we're saying that's m sub n plus 150. Okay, so it's very similar to that. But then if you notice here, m sub n, well, that has it right here where it has 20. So if I plugged in 20 right here, that would be where I would get over here, I would get our first term. And so that actually kind of goes along with exactly what we have right here, where we have 20 plus $1.50 times 0 would still get me 20. 20 plus $1.50 times 1 would get me that 21.50. Okay, 20 plus $1.50 times 2. Well, that would match that number that we'd have right here, where we have that 2 right here, and that would get us the $23, because it would be the $20 plus the $1.50 2 times. So that would be that 23. So this right here is the explicit function rule that you guys are totally used to seeing. You just might not necessarily have done this. And I will say you can write it as n is equal to 0, 1, 2, 3, dot, 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 or you could also just say n is greater than or equal to 0. Either of those work. All right, so here, use sequence notation to enter the data from your table in question 1 in a graphing calculator. I will go ahead and say that I know that the overwhelming majority of you do not have a graphing calculator, so we're not really going to work on that kind of functionality of things. But what I will go ahead and do is if you were to put it into the graphing calculator, you would end up with a scatter plot of sorts where you would have that initial point. That would be right here where our value is 20, and then we would see that it would be increasing by $1.50 every single time. And so what we would be expecting to see here matches exactly what we would get, and that would be that we would expect to see a linear function. And the reason that we would expect to see something linear is, well, what's that? That's a linear function. That's y equals mx plus b. Okay. So this would be a linear function. It is positive and increasing. Okay. And it's increasing at a constant rate because it is linear. And it's increasing by that $1.50 every single time. Okay. So now if we look at this next one, how much does Cohen earn if he sells 100 magazine subscriptions? Which rule did you use to answer this question? So consider what you have here. Are you going to want to use this rule right here? Where, okay, in order to find 100 subscriptions, I would have to find what 99 subscriptions looks like, and then add $1.50 to it. Well, how would I find 99 subscriptions? I have to find 98, and 97, and 96, the 95. So you see, using the recursive functionality right here that we have is not necessarily what we want to do. In this particular case, we'd want to use our explicit function. So right here, if I was going to go ahead and figure out how many we would have if we sold 100 subscriptions, we would take that initial $20 and we'd add $1.50 times 100. Okay. And if I do that, I put that in the calculator and I get back $170. Okay, so obviously we're going to choose the explicit function rule in this case because that has that input-output relationship that we're looking for there, that I can input the number that I'm looking for, the amount of subscriptions that I'm looking for, and get the output right away. Whereas with these, I would have no idea. I don't have an input for m sub n, or I don't have an input for m sub n minus 1 that I would need to get me 100 because it's so far into my sequence. All right. Cohen is trying to earn enough money to buy a new MP3 player. He needs $225 to cover the cost and tax on the MP3 player. How many magazine subscriptions does Cohen need to sell to buy his new MP3 player? Justify your answer. Which rule did you use to answer this question, and why did you choose that rule? Sometimes some of these questions just crack me up because they're just so outdated, and this is one of them. I mean, we're talking about MP3s. Okay, so in this particular case, he needs $225 to cover the cost of tax on the MP3 player as well. So um, what we would do is we could go ahead and we could take the explicit function rule that we have right here. We could go ahead and take that, and this M sub n, remember M sub n, that represents the amount of money that we have based on our magazine subscriptions. So that means then that I could just do that right here, and I could say 225 is that M sub n. This is M sub n in my equation, okay? And then I just have that 20 plus $1.50 times n. And now I can solve for n because that's how many subscriptions that I have right here, because n is the number of subscriptions. So I just took an equation and I got rid of my variables to give me just that one variable that I still need to solve for. So if I go ahead and do that, I'm going to subtract 20 from both sides. And that's going to get me 205 is equal to $1.50 times n. And then I would solve for n by dividing both sides by $1.50. And when I put that into the calculator, I get back 136.667. Okay, so, but that's not my answer though, because my answer is how many magazine subscriptions does Cohen need to sell to buy his new MP3 player? It's not 136.667. I can't sell 136.667 subscriptions. You can't sell a portion of a subscription. So in this case, is it going to be 136 or 137 subscriptions? Well, if it takes 136.667 subscriptions to break even and get that 225, that's the minimum amount that I need. If I sell only 136, I'm going to end up just short. So I need to round up to 137 subscriptions. So that would be my answer. It would be 137. Now, we could have tried to use the other rules if we had the functionality in our graphing calculator to do the sequence notation, but honestly, this one's just easier. And like I said, the majority of you guys don't have the graphing calculators. All right, your phone service allows you to add international long distance to your phone. The cost is a $5 flat fee each month and 3 cents a minute for calls made. Write a recursive rule describing your monthly cost for international calls. Then write a function rule for the n minutes of calls made in a month. Okay, so first it's telling me that I need to initially write a recursive rule describing our monthly cost for international calls. Okay, so that's step number 1, recursive rule. So I'm going to write that here, recursive. Okay. So with this recursive rule, what I'm kind of considering here, let's consider what our sequence is going to look like. Okay, so we've got the $5 flat fee each month and then 3 cents a minute for every call after that. That would be international. So we're going to start with $5 and then the next one would be that 3 cents more, so 503. Then the next would be 5.06. Then the next would be 5.09. So you see what I'm doing here is I'm just adding 3 cents every single time. And I started with that initial, that $5 flat fee. So when I take that information and consider what that recursive rule is going to look like, what we're going to consider here is I'm going to have n plus 1. You know what? Actually, I'm going to change that. I'm not going to do m. I'm going to use s. We used m on the last one, so I'm going to use s. So s, n plus 1. And the reason I'm using s is because of this service right here, right? So I'm going to do that. So this is saying that the next term is based off of the term before it. So the term before Sn plus 1 would be Sn, right? This is the original term. This is the next term, okay? And then each time I'm going to add 0.03 cents, okay? and then we're going to go n is equal to 0, 1, 2, so on and so forth, or n is greater than or equal to 0. Okay. And we can use that in this case right here because here 0 works. Okay. If this was the other one where we did Sn and this was Sn minus 1, then I wouldn't be able to use 0. I'd have to use 1. So we like this one because it allows us to use the n equals 0 as our initial amount. So we have that, and then that's exactly what we're going to also identify right here would be when S of sub 0 is, and that's that initial amount, that would be 5. So when I've had 0 international long distance minutes on the call or on the phone service that month, it would just be $5. That's what we would have right here for our recursive rule. Now our function rule. So let's do that. Function rule. Okay. So the function rule, again, that's that kind of, it's going to look like a linear equation, essentially, is what we're going to have here. And so we're going to say S sub n is equal to, and it's that initial amount, that 5, right here, plus 0.03 times n. And again, the n is going to represent the number of international long distance calls that we've done. So we would have that, and then we would just need to say that n is again greater than or equal to 0. And then we'd have our function rule defined for us right there, and our recursive rule defined for us right there. So truly, that's the gist of the stuff today is recursive rule is where you're going to have to write some sort of expression based off of the immediate preceding term to it. Not just the first term, but it needs to be the immediately preceding term. So if it's the 72nd term in the sequence, you would define it by the 71st term in the sequence immediately before it. But you have to know what that term is. And so that's why there's a lot of limitations on recursion and when to use them and how to use them. So we'll go into that a little bit further as we go through our unit. Let me know if you have any questions.